All right, now we want to talk about what is a gravitational field. So it's going to be a region of space that is going to surround a mass. So in order to introduce this topic, let's go back and talk about electricity. So that if you had a negative charge, and then you're going to take a teeny tiny positive charge, and you're going to let it go. Well, opposites attract, so that this charge would fall towards that charge. Now, let's take the same teeny tiny little charge and put it over here. Well, it's going to fall in that direction. And if you take the teeny tiny charge down here, it's going to fall in this direction. So this series of arrows, which kind of looks like spokes on a wheel, but in fact it is three-dimensional. So imagine a pin cushion that has pins pushed into the pin cushion in all different directions. This would represent the electric field of a negative charge. Now let's compare this to the Earth. So in this case, this will be the Earth over here that has a certain mass. And now we're going to take a teeny tiny little mass up here and we're going to drop it. So it's going to be attracted to the Earth, and then we could take it and we could drop it from here and it would do that. And notice it's the exact same picture. So this picture that represents the gravitational field of the Earth is identical to the electric field of a charged particle. Okay, so I want you to be able to draw the gravitational field of the Earth. Did you notice that these lines are getting closer together the closer you get to the Earth's surface? What do you think that means? It means that gravity is getting stronger. So the closer these lines get to each other, the stronger gravity gets. And we know that that's true because it's that 1 over r squared thing. So as the r gets small, the f would get big in order to compensate. Okay, then we also want to have a connector between the force of gravity and the field. So if this is the electric field, then this thing over here is the gravitational field. And so I make kind of a fancy G. So this represents the gravitational field, this represents the electric field, and we would like to have a formula that connects them. So we're going to say that the force of gravity is going to depend on the field. So we just got through saying the field is stronger the closer you get to the mass. So that's telling me that it's proportional to the gravitational field. So as the field increases, so does the force of gravity. And then it also depends on the m, so that you know that if you've got a box that weighs 1 Newton and another box that weighs 10 newtons, okay, the reason why this one is so much heavier is it's got more mass to it. So this formula is also going to depend on mass. So we got m times the gravitational field of the Earth would be the force of gravity on that mass. And notice we can do the exact same thing for electricity, where this would be the force of electricity is going to be equal to the charge Q, because that's what's creating the electric field in the first place, and then it's going to be times the electric field. So this is a little mass m that you put into a gravitational field. This is a charge Q that you put into an electric field. And so when you do that, this experiences an electrical force, and then this would experience as a gravitational force. Well, we're going to find out that the gravitational field has a particular number when you are close to the Earth's surface. And so that is going to be little g. So now we've got that the force of gravity is m little g, where little g was that 9.8 thing. So little g is equal to 9.8 meters per second squared, the acceleration due to gravity. That's the gravitational field when you're close to the Earth's surface. Now, we know that as you go up, okay, you see the arrows are getting further apart, so the gravitational field weakens as you go up into the air, just like the electric field weakens as you go up. So that what's going to happen is this g here is going to get smaller and smaller and smaller the higher up you go into the atmosphere. But as long as you're within, 10 kilometers of the Earth's surface, you don't have to worry about this thing changing, and you can just assume that it's 9.8. Okay? All right. So let's take a break. When we come back, let's talk about what energy is.